Anybody have a solution? What'd you get?
Well, 5, 6.
Negative
It's
5,
negative.
negative 6.
Yeah, sorry,
Yeah, that's what you meant?
Sorry,
Good.
so, yeah.
I'm going to just work through it. So did you multiply the first one by 2 and the second one by 3?
I multiplied the first one by 5. And the second
Oh,
one by
that
2.
works. Same thing. Okay, let's do that. So multiply the first one by 5, so you get 10x minus 15y equals 40. And the second one by 2.
2.
Okay. And this gives you negative 10x plus 4y equals 26. So altogether, your x's go away. You get negative 11y equals 66. So y equals negative 6. And then when you plug this back in, your x will equal negative 5. Do you want to see that part too? Or you believe me?
Believe you.
Okay. You could also have multiplied this by 2 and this by negative 3, or by positive 3 because they're opposite. 2 and 3. So anything to make it so that these something cancels. In that case, my y would have canceled. I would have solved for x and then gone back and solved for y. Okay. So look at the bottom of these graphs. This is what I was talking about the parallel crossing or, well, intersecting, or one line. So if you look at A, B, and C, okay? And here's where the new vocabulary comes in. For graph A, they're kind of faint, but you can see the lines intersect, and their intersection is 2, 4, 3. Okay, how many solutions is that?
1.
One solution. Now, here's the thing. So write 1 on the first line, but then on the second line there, this is where the new vocabulary comes in. We call this a consistent system of equations. When you get one solution, it's called consistent. So put that in on the second line. And then where you have parallel lines in the next one, how many solutions? None. And that's called inconsistent. So you have consistent and inconsistent. And then how many solutions in C?
Infinite.
Infinitely many. And that system is called dependent.
Dependent?
Dependent. So now we can find that what we can do, we don't need to graph to figure out how many solutions there are. We can, but we don't have to. Because we can look at the solution, or we can look at what happens when we try to solve it to figure out whether it's consistent, inconsistent, or dependent. And then on the next page, you'll see we can look at the slopes and y-intercepts. Okay? So, let's do number 5. And the question is, it says solve using substitution or elimination. So we can pick our method. How many solutions does each system have? They don't even care what the solution is. They just want to know how many. So the first one is 6x plus 2y equals 2. Okay? And then y equals negative 3x plus 1. Okay. Immediately, I see this is solved for y already, so I'm thinking let's use substitution. Let's plug this in for y. So I have 6x minus, or plus, 2 times negative 3x plus 1 equals 2. Okay, so I just substituted. So then I use distributive property. 6x minus 6x plus 2, because I have to distribute that 2, equals 2. Well, these cancel, so I just have 2 equals 2. This is what we call an identity. I don't know if that's the term your teacher used for algebra, or if you learned algebra on your own, but we call this an identity. It's always true. It does not matter what x is. X could be anything we want. This would still be true. So this is infinitely many solutions, okay? That's the situation where you have the same line. So we could manipulate these around and show that they're the same line, but we don't even need to. So that has infinitely many solutions. It's a dependent system.
So how do you know if it's no solution? Is it like
If then
2
you get
3?
something like 2 equals 0.
Oh, okay.
You get something that's never true, no matter what you plug in for x. Okay? So let's look at the next one. So in that one, we have infinitely many solutions, so that answers our question. Okay, in this one, 3x plus y equals 2. And 6x plus 2y equals negative 2. All right. Well, what if we multiply the top equation by negative 2? Then these x's are going to go away. Negative 2. Okay. So we're going to get 6x, negative 6x, minus 2y equals negative 4. We're just doing
You're
the
doing
low-tech
low-tech construction
But
here.
there's enough light.
Okay,
so,
good.
yeah. So then this one we're just keeping the same. So 6x plus 2y equals negative 2. So what happens here when I add them together?
4 equals negative.
Yeah, there are no more variables. You get 0 equals negative 6. So what does that mean?
No solution.
No solution. So what do I know about these lines?
Parallel.
Parallel when there's no solution. Exactly. Okay, so turn to the back. Now, let's fill in that chart. I think you guys can fill it in without my help. Okay, so we have slope, y-intercept, and number of solutions. Okay, so let's look at the case where we have parallel lines. What can we say about the slopes?
They're the same.
They're the same, they're equal. So the slopes, if the slopes are the same, what can we say about the y-intercepts? Go ahead and sign in and take one of each. What can we say about the y-intercepts with parallel lines?
I'm sorry.
What can we say about the y-intercepts with parallel lines?
Different.
They'd be different.
Yeah.
So if we have the same slope and different y-intercepts, then we have no solution. Okay? What if we have the same slope and the same y-intercept? Yeah, then it's infinite solutions. They're the same line. So infinitely many. And that's different than all real numbers. When we have an equation in one variable, we're on the back of the worksheet. When we have equations in one variable, if we get this identity like 2 equals 2, then it's all real numbers. But with two lines, with two variables, if they're the same line, these solutions over here aren't solutions, so it's not all real numbers. It's infinitely many solutions that lie along those lines. So that's a different thing. Now what if the slopes are different? Then it really doesn't matter.
Then it's both.
This can be either. You could have the same y-intercept. Then it's how many solutions? One, because those are intersecting lines. And it doesn't matter about your y-intercepts. Okay? So that means I don't even have to solve the system. I can put both lines in my system in y-intercept form, slope-intercept form, y equals mx plus b. Look at the slope, look at the y-intercept, and know immediately what kind of lines I'm dealing with and how many solutions there are. And that's what we're going to do here. So let me leave that up there. So let's look at this first one. We have y equals 5x minus 12. Okay? And then we have 20x minus 4y equals 48. This is already in slope-intercept form. I have a slope of 5 and a y-intercept, I'll make it b. Y-intercept is negative 12. I'm going to put this in slope-intercept form. That means I need to get y all by itself on the left. So I'm going to subtract 20x. And then I'm going to divide by negative 4. That's going to give me a positive 5x minus 12. So in this case, my slope is again 5, and my y-intercept is again negative 12. So what does that tell you about these lines? Same slope, same y-intercept, so they're the same line, right? So infinitely many solutions. And you didn't even have to graph them or solve. Okay? Now let's look at the next one. Okay. We have 2x minus 7y equals 15. I'm going to solve that for y first. So I'm going to say negative 7y equals negative 2x. I'm subtracting 2x from both sides, plus 15. Now I'm dividing both sides by negative 7. So y equals 2 sevenths x minus 15 sevenths. I went kind of fast, but I'm just putting it in slope-intercept form. Now I'm going to put the second one in slope-intercept form. We have 2x plus 7y equals negative 15. Okay, I'm going to subtract 2x from both sides. And then I'm going to divide by 7. Minus 15 sevenths. They have the same y-intercept, but do I care? Because they have different slopes. And if they have different slopes, it doesn't matter what their y-intercepts are. If I were to solve these, I'd get one solution. So these are intersecting lines, which means consistent. They're a consistent system of equations. You try number 9.
Wait, can you keep that up for a second?
Oh yeah, absolutely. What'd you get?
I got none.
No solution.
Yeah.
Parallel. So that second line, when you put it in slope-intercept form, you get y equals negative 3x plus 8. So same slope, but different y-intercept. Those are parallel lines, so no solution.